In the previous video, we looked at how we can factor polynomials by first using the factor theorem to help us identify the first binomial factor, and then using either long division or synthetic division to identify the others. We also talked about how you need to use a certain amount of guess and check to find that first binomial factor, but we can limit the amount of guess and check by considering the constant in the polynomial. So here's an example. If we want to factor this fully, we know that any constants in our binomials have to multiply to -6. So we only need to consider those when we're looking for values for that first binomial. So the factors of -6 are those. So we would start by plugging those values into the function to try and find a binomial factor. So let's start with the easiest ones and do plus and minus 1. Well, I've done those here. When you plug 1 into the function, you get out -8. That means that the remainder when you divide this function, or this polynomial, by x minus 1 is -8. So it's not a factor. X minus 1 is not a factor. When you plug in -1 into the function, you find that you do get 0. That means that x plus 1 is a factor. Remember that the number that we plug in we're calling a, and the binomial divisor or the binomial factor is x minus a. So if a is equal to -1, then x minus -1 is x plus 1. So if f of -1 is 0, then x plus 1 is a factor. Now we can find the rest of the factors by doing division. So here's our question, and I'm going to do long division. So x cubed plus 2x squared minus 5x minus 6, and we found that x plus 1 is a factor. Now you could do this by synthetic division as well, with -1 off to the left if you preferred. So x cubed divided by x is x squared. So I put x squared in a line above my other x squared, and then I multiply back. X squared times x is x cubed, and x squared times positive 1 is x squared. Now I subtract down. 2x squared minus x squared is x squared, and bring down the -5x. Now x squared divided by x is x, and x times x plus 1 is x squared plus x. Subtract again. -5x minus x is -6x, and bring down -6. -6x divided by x is -6, and multiply back, and I get -6x minus 6, leaving me with a remainder of 0, as I should, given that x plus 1 is a factor. So now I know that x cubed plus 2x squared minus 5x minus 6 is equal to x plus 1 times x squared plus x minus 6. And I can factor this just as a quadratic or as a trinomial. So it becomes x plus 1 carries down, and then I get x plus 3 times x minus 2. So my original polynomial, shown here, can be factored fully into this form. And if you wanted to check that, you could multiply it back out to prove to yourself that the two sides are equal. So that's factoring polynomials. We use the factor theorem to find the first binomial factor, and then we use either long division or synthetic division to find the others.